Hey everybody, sorry for the delay in the video. I was supposed to have this back out in September, and it's already November. But today it's the video that was promised. It's about genetics. I have four species I'm going to talk about. Just don't have the other one out here because the ball pythons, my female Hercules is a little bit big, and so obviously don't want to have to keep track of her the entire video, and I'm not going to cram her into a small bin just for the video. So I'm going to start off with leopard geckos, something a little different, because I really haven't focused on things with legs in these videos. So far, almost all my videos have been, well, no, the first one actually had no snakes in it. Forgot, I didn't even film the snakes that I did see on that trip. But, yeah, this video is going to be about genetics in general, and the thing that I can use the best to get the point across with some of these traits are leopard geckos. Leopard geckos have a wide array of genes and types of genes to talk about, and because there is a much wider scope for me to show you what they look like, I'm going to use these as a first example. Plus, I already covered the westerns to some extent. I'm going to cover them again, but with them, since I already talked about the three that I have, I am still going to talk about them, but I'm going to explain them a little bit more in detail. But on to the leopard geckos. Last video, you heard me mention things like recessive, dominant, and poshet, heterozygous, and homozygous. This video is going to kind of help explain what that means, because a couple of my friends, after they watched it, told me, I have no idea what you're saying. And I was kind of like, oh. I decided after doing the research into this video, which is part of the reason it took so long, this video is just going to be simplified, like what you need to know in basis of the pet trade. I am debating whether or not I'm going to do a full-on video on genetics as a whole. If I do, it's not going to be for a little bit, because I want to get a very good grasp on genetics as a whole before I try to explain it to other people. With this, I know what I'm talking about for the most part, because they're color morphs, and I had to memorize these all the time as a kid because I wanted to figure out what I wanted to make and what I needed to make it. So with the leopard geckos, there are quite a bit of morphs out there. I'd say they are one of the most popular, I'll get this out of here, one of the most popular reptiles out there in the pet trade. In terms of lizards, I consider them up there with bearded dragons. And for geckos, they are up at the top with crested geckos. I'll show you a normal first. I'm going to start off with each of these. I'm going to start off with what would be considered a normal or a wild type, which a normal or wild type is what their common coloration would be in the wild. With leopard geckos, though, their normal variant is a little bit different from their wild type, which sounds a little confusing based on what I just said. But what's in the wild usually are darker colored individuals with more melanin, more brown, more blacks to them in terms of their spotting, their freckling. And that's because the darker colors allow them to blend in more and are making them harder to see, which helps them evade predators. But all my normal-ish looking ones are over in this farther bin. So I'm going to talk about I'm basically going to talk about, I don't know, I'm thinking. Definitely going to show the normal. She's a high yellow normal, so her color pattern is that of a normal, but she has a bit more yellow to her. Hopefully this shows up pretty well. If not, I'll definitely display video of her on screen. But she has, spotting. She has a regenerated tail. That's why this part of the tail looks different, which in the video I'm going to do on leopard geckos, which should be here in this next month. I know I said that about the last video, but this time I'm going to have time to do them. I'll talk more about tail regeneration and leopard geckos and stuff in the video for leopard geckos. But, so she's a normal, and so you can see the yellowing. She has a little bit of orangish on her. Her name's Apollo. When I first got her, she used to have, it's almost all gone now, her original pattern, which is crazy to think about because she's just changed so much since I first got her. But she has orange patches. That's entirely what her color consisted of. I didn't really believe that she was normal until she aged, and then I was like, oh, she's definitely a normal. Which there's nothing wrong. I actually really do like normals of a lot of things. But the next gene I'm going to talk about is the albino gene, and that's just because albinism just kind of happens on a natural basis. Not very commonly, and you don't see it very often because obviously they're not going to live very long, and that's kind of morbid, but it's true because their bright colors make them stick out. Very, very contrasted to their environment. Let's see. Because there's also 3 strains of albino. I have multiple Tremper albinos, which is the most common. Second most common is the Bell. I have 1 of, and then I have none of the third, which is the Rainwater / Las Vegas variant. You cannot breed those 3 together. It will cause genetic mutations that will terminate the babies. That, and then if the babies aren't terminated, they will either have horrible spinal kinks and mutations along those lines that are just physical, or they will come out completely normal, but they'll carry both genes, and then it just starts mucking it up a bit. And I know it's kind of frowned upon in the leopard gecko community, so I've never done it. I've never tried to, but it's something interesting to look into on a gene level. But I'll show you the Bell first, because I only have 1 of her, and then I'll do a comparison shot with the 2 of them. But so this is my female Bell albino. She, as you can see, has a lot more pinks and yellows to her. Her eyes, you got a little bit of stuck shed on your chin. Her eyes are a silvery color, which now that the sun's going down, you can kind of see it a little bit better. She'll have her eyes open. Her eyes are a lot more sensitive than my other albinos. I'm not sure why. I think it has something to do with the actual color of the eye themselves. But on her, you'll also notice she has like a little skin tag on this side, and this area is kind of discolored. That's not part of the color morph. That was because of an incident that happened, and I'll talk about that in the next video, or one of the next videos. I have a few planned involving these guys. And then, shocker, both of my Trempers are in this cardboard tube that's slightly unrolled because it got wet in the first take of this. But here they are, snuggling together. So I'll get her out. The Tremper. Oh, you're coming out on your own. Sweet. Oh shoot, you're both coming out. So here's the female Tremper albino that I was talking about earlier. As you can see, not as much. She'll settle down. Not as much pink. She has a lot more brown going on. I'll do a side by side of them, just so you can see the differences. And then, like I said earlier, I do not possess a Rainwater / Las Vegas variant. So I can't really show you guys that, and since I haven't seen one in person, I also know that the colors don't always translate well in between pictures and seeing them in real life, like with Andromeda, the sassy hognose from the last video. She has a lot of red undertones, but you cannot see it whenever you take pictures. I don't know what it is with the lighting and stuff like that, but in person the colors usually look a bit different. But so for the next morph I'm going to talk about, and I'll talk about the original version of it before I talk about the albino version, since I have both, is the Eclipse gene. The Eclipse gene is a codominant, if I remember correctly, which means that it can be expressed with other genes in tandem, and it's not going to be difficult to get that to happen. So she has about a 25% eclipse in the eye that's not facing you, and about a 10 to 15% in the eye that is facing you, which means this eye has a little bit of black right around here in this area, but in this eye it's about half of her eye is black. That is because of the Eclipse gene, which increases melanin in the iris. And then her also, the pattern on her and that paler color seems to also be in tandem with the Eclipse gene itself. The Eclipse gene seems to not just affect the eyes, but also the body and color. Because a lot of the Eclipses I've ran into and seen at expos all look pretty similar to this. So it might just be something that, it might be a polygenetic trait. I haven't really looked that much into the Eclipse gene past the superficial-ish area, so, but I also, when I was looking stuff up, a lot of the information about the Eclipse gene is kind of outdated because they said it only occurs with certain morphs and it can't occur on its own. It does occur on its own. I've seen it in several individuals, and that is a normal Eclipse right there. So obviously it does. This is a snow morph, or one of the 3 or 4 strains of snow morphs. which in leopard geckos, that's kind of a common theme, is that one morph will actually have several strains to it. And a color morph is just the phenotypical, which phenotype is what is shown, a phenotypical expression of the gene. So it's basically just what they look like. Color morphs do sometimes have neurological issues or spinal issues, and then again, that all comes down to preference on what you want to breed and not. You should let the animal's health get in the way of producing something. You shouldn't let your own opinions get in the way of you making something. So let's say, well, I'll show you at the end. I have an individual with the Enigma syndrome. Enigma syndrome is kind of like what the spider ball pythons have and the carpet pythons, and it's the jaguar morph of carpet pythons. They all have kind of a wobble to them, and it's a neurological issue, and we don't really know what causes it. With the Enigmas, it's hypothesized that they don't develop part of their brain, and it's tied to that color morph. I'm against breeding Enigmas after my terrible experience with breeding them. I know that some people are breeding to get the wobble out, other people just don't care, other people substitute other things. It's kind of a mess. So that's with that morph. This morph is a snow, so like I was getting at with the multiple strains, I'm pretty sure this is a gem snow or a tug snow. But snows are essentially just xanthic in leopard geckos. But in, like I mentioned in the last video, I'm going to keep making references back to that one, I want to make snow morphed hognoses, western hognoses to be specific. And the snow morph in hognoses, and I think in, I want to say gopher snakes as well, it is xanthic albinos, but the snow morph in leopard geckos is just xanthic. So there is a bit of a difference between names, and that's to be expected because they're not universally swapped out. And so that's something to keep in mind when you're looking for a specific color morph or you hear about them. Just know that most of the time, especially if it's like snakes, they usually are around the same type of thing. But then translating that to, like, let's say like frogs, because I know some frogs do have color variants and color morphs, they don't translate. But so I showed you these guys in here. I showed you the, oh, I skipped what I was going to show you guys, the Tremper Eclipse, because I showed you the regular Eclipse. I'll show you the Tremper Albino Eclipse. Because I do have him, he is hiding in his cardboard tube, but his, oh, he's shedding full on right now too, so you guys might get to see that on camera if I can get him out of the tube. I'm separating the tube because it's like, I have more than one of these. This one was wet already. I don't want it to grow mold on accident. But yeah, he's shedding right now. That's fantastic because you guys might get to see his color. Whoa, 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 little bud. But yeah, so he has, darn, that actually, let's see if I can, hopefully you'll get to see some of the color going through there. But he is also that same yellow and brown that this girl is. Oh jeez, she didn't want to stay still. But they're the same type of brown and yellow color pattern. Just he has a little bit of a bold stripe almost going on. But for his eyes, he's about a 50% on both eyes for the Eclipse gene. So the front half of both of his eyes are black, but the back half is normal. And it's kind of interesting, the Eclipse gene is actually very variable. And what that means is that it varies from individual to individual. So, as I said with her, one of her eyes is about a 10 to 15%. The other eye is about a 50%. Both of his eyes have 50%. And then my mystery gecko that's in here, she has two different full-colored eyes. One's black and one's red. So, and that happens when you mix genes. Her, though, I'm not sure why she has two different eye colors. That's not very common. I've actually not heard of that happening in terms of them being full eclipses but two different colors. So I'm actually going to ask a couple people about that, both at this upcoming expo. Well, it's upcoming at the moment. I don't know if it will be by the time I upload this. And a couple people that I talked to online about color morphs, because they have way more experience than I do, so I'm hoping they can help me figure out what she is. But before I get to her, she's going to be kind of the last thing I'll show for the leopard gecko section. The next is a form of patternless morph. Now there are two forms of patternless in leopard geckos. There's the Blizzard, which is this girl right here, and then there's the Murphy's patternless. the Murphy's patternless, who I believe is also in here. Yeah, he's in this cardboard tube. Oh, he's brightening up too. That's great. So Murphy's patternless, to some extent, can change their color, just darken and lighten, but all leopard geckos can do that. Hopefully, let's see if I can get that in shot. That's the difference between the two. It's not the size, it's the color. And Murphy's patternless do have an actual pattern when they come out. Blizzards are pretty much all one color, which can be all yellow, all white, or all black. And the trade names for those are Banana Blizzard, Regular Blizzard, and a Midnight Blizzard, respectively. And she's just a regular blizzard. She's starting to develop some yellows, but it's not enough to be considered a banana. But in the Murphy's patternless, they have a pattern. He's sadly, so as they age, the pattern fades dramatically. He's too old now for me to show off that cool pattern. But if I produce any, which I'm hoping to breed him to my Bell albino female to get albino patternless morphs this upcoming breeding season. If I get any, I will definitely make sure to video those just so that you guys can see the pattern. But for my next group of geckos, which I also want to mention before I continue, these geckos are not in the cages that I normally keep them in, or their bins. I keep almost all of them in bins just because it's easier for me to keep humidity in for when they're in shed or they need water, and to clean. And that's something I'll talk about later on, not in this video, but probably in another video, about bins versus cages and what species do better and why one's more useful than the other. But these two are not cohabitated, they are both separate. I do not keep 4 geckos in here, I keep 2 as a pair, and then this one's kept by itself, and then there are 2 geckos in here as a pair. The rest of them I put them in here just to show you guys so that I wouldn't have to be constantly swapping out bins. Oh man, you guys already messed up the paper towel. But these two, I'm very excited. I want to breed them. I don't know what will come out. I'm pretty sure they'll all be just normal babies, which I'm fine with that. This girl, I'll talk about. Okay, maybe you want to come out. This is my boy. He's a tangerine. And a tangerine morph is pretty much self-explanatory. It is orange. He's actually a very beautiful individual. They're becoming pretty, well, they've always been pretty popular since I've gotten into them. They've always been very popular just because they're very bright, they stick out, and then on top of that, since everyone's making them, they're not that expensive. They're one of the cheaper color morphs. So are the hypos, which is what this female is. I have 2 hypos. Let's see. This one is just way more handleable, that's why she's in the video, plus she's already paired up with him. So, as you can see, she's kind of more of a muted yellowish color. She's not quite orange, but not quite yellow. She's muted out. She doesn't have a whole lot of spotting. So and the hypo stands for hypomelanistic. I want to mention that too because it could have been hypoerythristic, which involves red, or hypoamelanistic, which hypoamelanistic. Actually, that is a very weird way to put it, but it just means that there's more dark, so it's essentially melanistic. Hypoamelanistic is just amelanistic. Hypomelanistic is not the same, though, as amelanistic. Oh, jeez, they're all trying to get out. But this female right here that's climbing over, her name's Houdini. She escapes things all the time. When I keep her by herself most of the time, which is what I used to be doing, she'd escape all the time. And she would get into other cages with other geckos. Now that I have snakes, I don't do that, and since I know that she's just wanting companionship, I keep her with the female that's in here, the female Eclipse. I keep them together because then at some point I want to have a breeding trio of the boy Tremper albino Eclipse with the female Tremper and the female Eclipse. So then I can get pretty much all 3 of those genes, well, because she's also normal, all 3 of those genes to be expressed in just 2 pairings. But now that I've hit the end of these color morphs, all the ones that I have out here, I will show you this girl. So she's hiding in her cardboard tube. She's very light sensitive. In the first take of this, it took a little bit of effort to actually get her out of here. And she didn't open her eyes up for the camera at all. Let's see, come on. She's really unique looking compared to all the other geckos. So that's why I'm not really sure. I was told The male I bought was a dreamsicle, which is a complex morph. It's a polygenetic morph, which means it's comprised of several genes, and a raptor female, which a raptor is a red-eyed albino female. And technically, he was sold to me as a raptor, but he doesn't have the red eyes. And a lot of people are just saying, oh, if it's an albino in Eclipse, it is a raptor. But I don't know if that's actually legitimate or not, or that's how you tell. But I think that's how they're deciding it now that people are trying to not use enigmas, because that's one way that you get raptors. But here she is. She's very white colored with like a tinge of yellow. She has a bunch of freckles that are dark brown, which shows that she is in fact definitely has a tremper, which I already knew that because the pairing, both parents were trempered albinos, so I knew she was going to come out albino. But one of her eyes is 50% black, 50% normal, and the other is 100% red. So it's interesting that she has the two different colors in her eyes, because it should be red on both. But that's... She also, as you can tell, let's see if I can get her in frame doing it. She'll wobble. She wobbles while she walks, and it's a little disheartening. It's why I stopped breeding leopard geckos for a while, actually, because she's the only one out of her 12 clutch mates that made it. The mom, for one of the clutches, had 4 eggs, which is not very common for leopard geckos. They usually have 2, at most 3. So for her to have 4, that was really weird. And then she just kept pumping eggs out, and I actually, even after I separated her from the male and realized that all the babies were coming out with genetic issues, she still kept laying eggs that were fertile, and they ended up dying. So she is kind of a mystery. I'll keep updates on her as she ages. Sorry about that, I hit the max time for the length of the videos that they can be. But as I was saying, the female girl right here, she's a little bit small for her age. By little, I mean very. So much that it worries me. But I think it has to do with the faulty genetics of the pairing. And I don't have either of the parents anymore. Both of them passed, sadly. And so she's the last kind of remembrance I have of both of those geckos. They were some of my first. But because of that, I'm being very careful. I'm first going to wait for the first clutches to hatch. If there are any problems, I'm going to cut the males off immediately from the female and try to get the females to reabsorb those eggs. But now I will get to the Western Hognoses. Even though I've already discussed them in some detail, I'm going to discuss them again. As I was saying though, I'm going to do the Western Hognoses next. I had to switch cameras because the other one ran out of memory. And we don't have any other format cards that can fit in there. So they're formatted cards. So this, of course, he goes in. The one time I want to show him off. I already talked about these guys like I previously mentioned, but I'm just going to go over them again kind of quickly. But, hi Percy, come on. He's due for a tub upgrade, by the way, so I'm probably going to be doing that here soon, in the next couple of weeks. Because Andromeda already got hers. But here he is. So, first I will compare and contrast the wild type versus the albino and hognoses. Now, it's the same concept as it was with the leopard geckos, with the albino being homozygous for the albinism trait, and the only way to get to the albino trait is to have 2 wild types that are heterozygous albino, which means they carry the gene. Let's see. I see her moving under here. Let's see if I can get her to come out. She's doing her thing. There she goes. Oh, you're being sassy. So, here she is. As you can see, there are obvious differences. Like, he is missing most of the pigmentation, so he looks orange. But, so this is the albino. This is a normal, or a wild type. She's more along the lines of, like, the beginning of a red line normal, which a red line is just the bloodline of it. So there are in the wild red, green, and yellow tinted animals. You can try to breed that into a specific individual to heighten the colors. So there are some out there that have a very vibrant yellows, greens, and reds to them. Those would be the green hypos, I believe, or the green phase, not green hypo. The green phase normals, the red phase normals or high reds, and then the lemon ghost, which sadly I don't have any of those to show. I know I said I was going to try to not show off things that I don't have to show, but this is also going to be short again just because I don't have a whole lot to show. Like the Leopard Geckos, I had a lot of different variations of things to say and to show. So these guys, again, not a whole lot. I have two animals that are homozygous recessive traits, which is my albino and my axanthic, which the axanthic is also a heterozygous trait that normals can carry but won't be expressed until two of them that carry the gene meet and have babies. And then the babies will express it as well. What I'm excited for is there's the possibility of this female carrying the traits of albinism. If she carries those traits, I'd be ecstatic, because if I breed him to her, 25% of the babies should come out albino. Whereas if I were to breed him to her, all the babies would come out normal, all of them carrying the albino trait. So that's what would happen if you breed something recessive to something normal, or dominant, I should say. And a good way to visualize it is if any of you have done Punnett squares, you're going to know what I'm talking about, but in this example I'm going to use M's. So a big M with a little m is something that's heterozygous. And something that's homozygous is big M, or little m, with the big M being the dominant trait, the little m being the recessive trait. If you breed a double big M animal to a double small m animal, all the babies will come out big M, little m. But if you breed a big M, little m animal to a little m, 25% of the animals will come out with two little m's, and the rest will all be big M, little m. And that starts to get a bit more complicated when you have two recessive genes competing against a dominant gene, which is would be in this case the wild type. So more than likely I'm going to get all normals that carry both traits, which either way I'll be happy with just a couple of albinos, with the rest all being normal, or all normals, because the normals are pretty variable, and I want to try to line breed a couple if I get the opportunity to. But like I said, this is going to be kind of short. I'm already kind of reaching the end of this one. Tricolors are going to be even shorter, just because there aren't a whole lot of morphs to begin with, and I do not have any of the actual, what are considered morphs yet. So, like I said before, the tricolors, I don't have a whole lot to show off, because there are some more peach-colored morphs, and I do have a female that is considered a peach-colored morph. It won't show up on camera, I learned that earlier today. It doesn't show up as well as it does in person, I should say. But if I can get her out, yeah, hi. She already knows what's going on. She saw me take the lid off. She saw me moving everything around. But yeah, she's my biggest hognose. Here she is. She's looking a lot more red right now, especially because of the sun. But in more direct sunlight, she definitely looks more peach-toned. But she, still has a lot of the red to her. She also has a solid black belly, which I'm mentioning that now because there is some belly color morphs, it looks like, coming out, which I have an individual that, if he proves out not to be a different species, and is in fact the same type of Tricolor Hognose, which, get into that, I mentioned earlier I'm making, or at least I hope I did, that I'm making a Leopard Gecko morph talking more about Leopard Geckos. I'm making one just on Western Hognoses, and I'm making another one just on Tricolors. Tricolors is going to be a little interesting because the area that they inhabit, there are also other tricolored hognoses. She is a Lystrophis poulture. I keep using Xenodon. I need to get over that because that's not the genus that they are in anymore. They are now classified as Lystrophis. But she's definitely a Lystrophis poulture. For him, not really sure yet. Need to do some more research into that, how to tell them apart. But I'm very excited either way. I sold them as a tricolor, so I'm taking the vendor's word for it. But I'm excited. He also just shed. I got that earlier. but sadly I had to get rid of that take because ran out of memory and didn't realize it halfway through, and I ended up recording about an hour's worth of footage that isn't going to be used. So I'm doing my best to recreate it to some extent, but with her, she has more of some muted white stripes. Let's see if I can get that on camera. She has some muted white. It's like an off-white tinted with like like gray almost. Whereas the male, not only, so I mentioned her black belly, he has white sides on his belly, and then he has some very vibrant whites and reds on him. Like, his reds are crisp, but they're not vibrant. That's how I should put it. His aren't bright, they're just a good solid red. And then he has the white. And so I'm excited to see what these two make, because what I've heard is that for the wild types, which these are the wild type variants, I wanted to get that out there, because when I first got into hognoses, especially western hognoses, I saw these guys online and thought that they were actually a color morph. They are not. They're their own separate species. These guys come from South America. The western hognoses come from North America. And then, mentioned earlier, these guys are getting their own videos, so are the westerns. I'm also going to try to make a video on South American hognoses and one on North American, but that still won't be for a little while because I'd like to get at least some footage of some more species belonging to each genus, just so I can give a broader sort of vision on what they look like, because not all of them look the same. There even is quite a bit of variation in the North American species, and there's quite a bit of variation in the South American species. I'd say there's more variation in the South American than the North American, and so those are some I'd really love to cover, and that's just kind of depend on what type of opportunities I end up getting in the years to come. But the South American one's going to be definitely down the line. North American, again, probably down the line, because a lot of them, if I want any to be able to actually show you, they're going to have to be wild, because there's not a lot of places I can find to buy them, and at the moment I'm very content with the amount of animals I do have, and I'm not looking into buying anymore at the time being. But yeah, I'm looking forward to making those videos. I know it's going to be a lot of hognose related content coming up. So if you're not really into hognoses, just let me know in the comments what are some things you would like to see. Because I am going to be making some other videos, but I'll get to that at the end of this one. Keep jumping ahead of myself. Next is going to be the ball pythons. I didn't bring them out here just because I didn't want to confine them to something small, because my female is about, I'd say 5.5 feet. And it just wouldn't be fair to confine her into this, and since they're going to be the last, it would be fair. And they're just, the only reason they're last is not because I like them less, it's actually because I have less knowledge on them. They are very complicated to me. I only know a handful of morphs still, even though I've been looking into them, with my favorite ball python morph being the urban camo morph. But again, I can't really show any of those things off because I don't have any. I just have a wild type / normal, and a G-stripe, which is a genetic stripe variant. There are multiple stripe variants too, which that confused me for a little bit. But I'll go get them. So as promised, here are the ball pythons. This bigger one, Hercules, she is a normal / wild type. So this is the dominant, one of the dominant traits, whereas this one, the smaller ball python, he's Cheerio. His morph is a G-stripe, which is a recessive trait. That is, he is homozygous for the recessive trait, which means that when I breed these two together, they'll produce all normals, so they'll look like the mom, but they'll carry the gene of the dad. Now, for ball pythons, there are so many morphs out there, and again, I only have 2, and it'd be kind of, that's its own type of topic, is ball python genetics on its own. So, like I said, this is going to be a shorter section just because I only have 2 of probably thousands of morphs and morph combinations. So, that's pretty much it for this video. So thank you for watching, and keep your eyes peeled for another video that's going to be releasing soon. I'm not going to tell the topic because this one was kind of a surprise and was kind of spontaneous. Have a great day, you guys.